Hello, everyone. Today I will quickly show you how you could build private applications with Gemma. I've already had one technical issue today with the demo, but hopefully you will see also the concept, and walking you through this, I will explain you also what's the difference between multi-agent and multiple agent systems. So first of all, if we think about a system where there are multiple agents, we think about a system where input and output from one agent comes to the another. So when we start something, we have, for example, in this case, our multi-query retriever, then the output from the multi-query retriever goes to another LLM and so on and so forth. So those agents, they don't really interact with one another. And then the first changes, or actually then one of the implementations is, for example, via LangGraph, where we create a process, a flow between those agents from one to another. We orchestrate them, we configure them, and we manage the interactions between them. One agent can only interact with another if we program them to do it. However, if we think about how we build software right now, so we usually have situations where we have tasks in Jira, or we have tasks in Trello or any other tools. And then we have a team. Usually the team has people with similar roles. The team could have people with different roles, like we could have marketing manager, we could have full stack developer, front-end engineer. And there are tasks that are specific to them. Like you will not ask a front-end engineer to do backend, but for example, if you have full stack engineer, they can do backend, and backend engineer can also do backend. So suddenly we can send one task to multiple agents, and those agents can also interact with one another. And this is what comes with this hierarchical architecture. This is where, for example, framework like TrueAR or AutoGen comes into action, where we can orchestrate the communication between the agents. They can communicate with one another, and basically facilitate problem solving. Let me see. I'm getting here pinging. Okay. So if we think about these architectures, have you ever built LangGraph or similar tools? You probably know that there's a lot of code to be written. And good for us that we are in 2024, where some parts of code could be written by AI, but we also have very good low-code solutions. Two of the most popular ones that right now for building strictly Gen AI applications, Flowwise and Langflow, where both are based on LangChain components. Flowwise gives us the opportunity to code in JavaScript. Recently, they've also allowed using Python. And Langflow, it's mostly Python-ish. One thing, though, they give us this interface where we drag and drop. However, none of those tools is actually fully no-code. I will see you will show it shortly in the example what I mean by that. So about the Langflow quickly, so it's owned by DataStax. Mostly one-to-one LangChain components could be used. You can use also vanilla Python there. It could be deployed as a Python package, or it could be deployed as a Docker container. And there's also like a managed version. So my preference is usually Docker containers, and it's mostly because, well, it's easy to set them up. And for front end, you can use, let's say, even Streamlit. Gives us quick prototyping techniques. In the repo that I will share with you shortly, you will see as a basic Streamlit application, like literally 180 lines of code where we can use Langflow flows and 11 labs for fun. So if we think about building the simplest multi-agent prototype, this would be the solution, where the front end, if the app is not UI intensive, because let's be honest, Streamlit is not the most fancy solutions. And then we have Langflow, where Langflow can interact, for example, with vector stores like Quadrant that we can also self-host, and it requires Postgres, so the relational database, to be running. Then if we up our game or we are low-code masters, we could use NAN, which is also using additional databases. It could be deployed as a Docker, and we can create a simple if this then that flow, something similar to Zapier or make.com if you know those solutions. And this could be running locally. This could be running as your webhooks. And most of the code there is written in JavaScript. However, they've added recently beta support also for NAN. Then I would say the most traditional stack right now for like a low-code-ish solution is building Next.js. You could use bolt.new, you could use Lovable. Both solutions can create a quick UIs for us, including a backend. And then we have Langflow, where we are still using Quadrant and all other services. And if you go with your project to production, most probably you will be replacing Langflow. It has its throughput. It's scalable horizontally. So if you want to be able to show more and more actions, more and more users, then, well, you would need to deploy more and more machines with Langflow and have some load balancer on top of it. This at some point could be easier with Fast API or even LangServe. So LangChain serving service, which is also based on Fast API on the backend, could be your go-to solutions. And then usually we'll add a little bit more of databases like MongoDB and Postgres for also storing additional information by our users. Like you can keep conversations in MongoDB. You could keep some non-relational data, like let's say you are scraping some information, and it's not necessarily something to be put into vector storage, though then you can use MongoDB to keep the data. Okay. So if you would like to see the repo, here's the quick link. You can also, if you want to connect on LinkedIn, feel free to send me the connection. On GitHub, you will see the code. So let's maybe move to the code. So for this, we are using Docker Compose, where we have Langflow container. Oh, just a second. Let me switch the screens. Okay, we are back. So on the repo, you will be able to search through the Docker Compose, so basically which kind of containers we are going to deploy. And you will see the Streamlit application. So as I've promised, literally 170 lines. And it's all. So for all the chat interaction, you will be able to see, to read them aloud. I'm also deploying this application as a Docker. So you will find also my tip, how to do it, to keep the images small. I'm using Poetry for managing the dependencies. It's been working for production deployments for me for a while. However, there's also Rye. I haven't yet deployed to production, hence, well, starting today only this solution. And Streamlit gives us option for an interface like in here. For local development, I also suggest to use Conda so that we can manage the Python versions easily using multiple projects, and some of the projects are on a different version. And if you've been working with LangChain and the technology already, you know that the dependencies are a hell very often. You could see also the .env template where you can fill in it with your credential for 11 Labs, Langflow, Google API if you would like to use AI Studio, and other solution providers. The thing is, though, that if you want these credentials to be accessible on Langflow, there is one additional step needed. So Langflow variables to get from environment. You need to add your .env environments in here. With this, remember also if you are changing the default passwords to the databases, it's deployed on our machine. That's why I gave us the option to do it a little bit less secure passwords. However, if you are gonna deploy it on production, definitely change them up. And this is also where you change them in the Langflow database URL. Plus here on top for the Postgres. One thing is that you don't really need to create the tables, the users for Langflow. Langflow is doing this for us. The only thing is if you really would like to have custom users, because right now Langflow will be using the root user, then you need to create an additional file, init SQL, where you have like initial comments that needs to be run on the Postgres container. So you probably see also here on the bottom my Docker. I'm already running the containers. So it's Streamlit. So we have our Streamlit application, we have our Langflow, Postgres, and I'm running Quadrant application. Good. There's also a README file. So I've been working on this instruction. So with each workshop that I'm doing, I'm trying to add more and more information here. So feel free to drop any comments, or if you want to make fork and PRs, feel free to do it. I'll be reviewing them, or ping me on Discord or via LinkedIn. Okay, so let's maybe switch to Langflow interface. So once you start Langflow, as we configure it in here, I'll just show it to you. We are configuring here port mapping. So we have our host machine port and the Docker container port. And for example, for Postgres, as I'm not really keen into getting into the Postgres and messing up with its data, I'm not sharing any ports, but at the same for Quadrant, so that we can view our collections. It's sometimes nice to share the ports with the host machine so that we can view it there. And all those machines can connect with one another via network bridge. Okay, so let me switch again screens. And we will be in Arc. Perfect. So we can build this whole system to be fully local. So as you could see, we can have our Quadrant here, where we have, there should be one collection. Yay, it's here. So I've put in here a few of articles and documents about product management that we can use later on for our pipelines. And here we have our Langflow. So I already have a few components here that I've built over the time. you have them also in the repository as custom components folder. And as I mentioned, why I even need those custom components? Well, mostly because the system is still low code. So, for example, we have our quadrant block. So let me compare it with the traditional quadrant. It looks a little bit different, mostly due to personal setting. However, if we dig into it, we are seeing that this component is still using LangChain community. And if you are more or less up to date with what LangChain is doing, they've switched to packages per provider or per third party in like 2 versions ago, like in version 0.2, as far as I believe. And in the end, it's using a lot of the native client. So I've given it a boost, and I've migrated it to it's using this guy. Okay, never mind. I've migrated it to a quadrant vector store here, and we have quadrant from a document, and this is not the right component. Let me quickly preview the more complex flow first. Sure, this should be it. I have also one more version for actually ingesting the information here, where I believe here, yeah, here. Here I already migrated it as to a retriever solution, not just another block. There's a lot of playing around. We can save our components as we are done with building them. We can click on save, and we have our own quadrant saved component there. You have also, when you start with Lightwave, you can also select one of the built-in flows. Okay, let's start with this simple flow. So let's say we have our quadrant. We still need to have an embeddings model. So let me quickly use one that I have pre-configured. So generally, retrieval augmented generation works in a way that we are using the vector or like dense embeddings. So like vectorization of the text, we replace the text in a way that we understand it into numerical representations of vectors. And thanks to this, we can also calculate similarities between each of the documents. Probably it's very basic for you information, but for those who haven't been yet building RAG pipelines, this is why we can find the right documents from thousands. It's not, we can use obviously keyword search or find specific words, but we can also use the vector representation. Okay, and we need also chat input here. So to build our pipeline in here, we are using chat input. So it's our input to the flow. This chat input will be then run against quadrant. So to find similar documents, those documents later on are being parsed. So we use XML-ish. So we wrap them in here. Then this should be a part of our prompt. Please answer the user the below question. Good as you. I'm not the master prompt engineer. As good as you can using context. And let's put it as an instruction. Here we could do some tildes. And our context. We could add also some backstory, as I know what my vector store is about. Then we again drag and drop it. We need to also pass our question. And here we go. So I really thought that I would be able to use Vertex AI. So we have specific blocks for Google here. However, I wasn't being able to get access to Gemma, to deploy Gemma models with my account. You can access Gemma models for sure from Colab. You can also access them via AI Studio. However, not surprisingly, not via API. Maybe you have some hacks how you are using this. You can definitely use them as Olama. I can show you it locally. However, I haven't been able to quickly deploy Olama. We can maybe go through it together if you want as a Docker to this app, and then we can access also this Olama instance inside. So if we are ready, we can just click play. And now the model, something from the model doesn't like it. And we have an option here to check what's wrong. Okay, so there are arbitrary types allowed. Most probably there is some issue between the dependencies and how I deal with that. So most of the cases, I just go through the definition and look for things that could be improved. This is chat, Google component. Oh, interesting that it's launching Google Gen AI. I think package. Let me quickly see. By the way, you have already your troubleshooting guide, and we have Google AI. This is text completions. Okay. Welcome to the life of Gen AI engineers. Let's go back to chat models and integrations, Google, and we want to use Google generative AI. Okay, so that's the right component. We could actually do the component import on top. Interesting fact is that actually this block has been working for me previously beforehand. So we could clean this up. We have the model, max tokens, top M, top K, and Google secret string. Okay, this might be the issue. Model Gemini Pro. Let's see. 1.5 Pro, 1 Pro. And let's see how it runs right now. As this pipeline is actually short, but arbitrary fuse. But if you have longer pipeline, you can freeze the path in here, especially if you have multi-agent system and you just are testing one of the agents. Let's see advanced fields here. Google API. Max token. Keep some of them. I don't need those. And I believe there is an API key property, not just Google API key. Okay. And in those cases, we can also look through the specific package implementation on LangChain. And yeah, the reference is wrong, but we can search for it online. And then we are getting to the docs. And now hopefully we'll know what was the not yet API reference. Callbacks, credentials. Google API key. So API key is correct. And let's see with the smaller amount of blocks in here. Temperature. And let's go. Google API key. So let's keep on removing the unnecessary. Seems like Langflow started to have some problem with them. Interesting. So let me check the pipeline that I know that were working previously. So we have here the deployment, and it's basically the same. It seems like when I was trying to fix the Olama version, this is the place where my model stopped working. So if we can deploy Olama as a Docker as well, as I believe. And for this, we will need, most probably will be pulling the image, Olama, root Olama, install yum. Mm. Let's try with most basic one, so we can pull the image. And I will try to spin up it via Docker Compose. So let me switch my screens and we'll be in the Visual Studio Code. Okay, let me know if it is more visible right now for you. Olama latex, wow, it is crazy. Let's see Docker image. Quickly, if it's pulled, it's still extract. Wow, it's a hell of a big image. Okay, we'll need to share parts with it. So I'm using a code stral for auto for the IntelliSense. Okay, so it wanted Olama without models. Good to just named volume. And I like to add networks. Name was node network. And we can add alias Olama. We don't need PGWeb. Now, we need to add volume here. Olama, root Olama, port. Perfect. Okay, it's been up Olama. Now we should be able to connect to it. Oh, by the way, I can quickly show you how it runs locally. I'm using i9 MacBook, so I'm not on the latest one. That's why I'm not running all the models locally. However, we can try out with Gemma model. So once you start Olama, it first of all needs to load the model to your memory, and now we can run some prompt. I think I have some prompt there, like let's go with what is the best project management methodology for startups and why it is not waterfall or agile. And the speed is not that bad. I mean, it's more or less the speed of how I'm reading. However, if we go with 7B, oh, there's no manifest for itself. IT, and let me remember right now the name. But If we go with the other models, well, it is slow. Model name. Let me quickly find the model names. Oh, we could even use code Gemma. Oh, it's 9. Yeah, 7B was the previous editions. Oh, it should be 9B. As you can see, even loading the model is a little bit longer. Even though, well, between 2 and 9, maybe it's not that many. So let's add our question. And now time to the first token is drastically bigger. That's why if you are working through, now it's super slower. So that's why if you want to have a solution that's including like deployment on smaller machines, like on mobile devices, why not? You could deploy, those models definitely are being aimed to deploy on mobile devices, then use smaller models, maybe even fine tune them. Okay, but let's see how it's gonna work with maybe 2B with our line flow. Okay, so now our Docker container should be able to connect to Olama. It's not loading because there are no models. But we can go to the container and quickly pull the model. So it will be docker exec -it. Mm, yeah, let me share the terminal. So to pull the image, we have a pull command. So for example, we could run Olama pull Gemma Olama 2.2b. And now it's pulling the Gemma model. And good that I have quick internet on my laptop. But keep that in mind as if you are pulling bigger models like 27B or something. So here we can see that this is 16 gigabytes. Well, we are pulling here only 1.6 gigabytes. Perfect. Now, if we go back to Langflow, I will be able to choose the model. Perfect. So previously you could see that I haven't been able to select any models. Now, hooray, we have something. Oh, we can copy this block, Command C, Control C, go back where we had our generative AI issue. That's interesting. I will check later on what was happening there. We have our prompt. Let's change the llama because this is inside Docker network. We choose the model, and let's give it a spin. Huh. No validator. Oh, something is definitely not working for my installation today. For Olama, I guess I could try to reboot the container quickly, and let's see if it fixes, because I was trying to hotfix some of the issues. I'll just quickly restart it. VS Code. The good thing with the Dockers is that whenever you mess something up, you can just restart the container. Okay, and it's taking some time always to spin up because it's installing some dependencies in the start. Mm-hmm. So now let's see if it's running. We start with a chat message. We have a quick quadrant. You can also use, if you have better computers or you are doing it on a server, you can use Olama embeddings in a similar matter. We just need to pull the model there for the embeddings. Yeah, it's generating. And we have a quadrant here. Then we parse the results from quadrant. Oh, it's still running. Commenters for a question, you could say, okay. So let me unfreeze the things. And as it's running, we can add chat output. Yay. And now here's a magic button. We can click here to clean it up. And we had, what's the best project management method? Too much. Copy paste. Now we can close the window here to see also what's happening with our within our project. So it got the question here. What's the best project management method? Then we have the search result in here. We have 4 search results about product management method. Then we have my phones are spinning. Then we have how it parsed this. So it parsed this into the documents. Then we have the final prompt. So here we click for the output also. It's a little bit longer. Obviously, the instructions could be better here. That's something very depending of your use cases that you are coding. And well, the output will be ready when the Olama finishes, but you can also try to configure it into streaming. Not probably. You would need to modify a little bit of the implementation, because I think there's no RPC in here. But at this stage, you can work through vanilla Python code. It's not the fastest on Docker. But I can hear my laptop. It's on 90 degrees right now, trying to run it. If you want to optimize this time, first of all, you would need to go with streaming. It gives you this option of potentially having something happening while you are coding, and at the same, it makes integration a little bit better, because if something fails during the generation, you are losing everything. But if you have been streaming, you are at least having whatever has been streamed through. And yay, we have an answer. Hooray. Okay. If you are eager to play more, so let's see how we could use our llama here. Obviously, it will take a lot of time, so maybe I'll just do a quick show of a few features, what you can do. So imagine we want to use a multi-rack component. We need to have our LLM. So we could do, let me zoom it in. So we have our Ollama LLM. We drag and drop to the LLM of a multi-query. So this is a custom block. So I created a custom block for LangFlow for this guy. And what it does, so we have a prompt in here. It's a similar prompt to a research agent. So you are a citizen research agent. Here is a question, and I need to rewrite the question a few times. Then we have Stavely as a retriever, and the Stavely should give us 5 results for each of the queries. And the queries are based on the question on top. Question here, tell me a lot of why startups fail. It's a rough time also for startups. Oh, you can build long chains here. I think my record is around 50 agent, and it was still working pretty well for a prototype. You can definitely go higher. I just haven't had, I'm counting agents, not the blocks here, because look, this is more or less one agent. This multi-query retriever is one agent. Here we have Google agent, then we have Bedrock, Azure AI. I'm mixing also models, because if I'm using LLM as a judge, you shouldn't use models from the same family for judging and results. Okay, let's see if it's gonna give us some answers shortly. And I will also check YouTube questions. Okay. I see a question about the documentation. Well, you have the repo, so I can also drop the link to the repo. More or less, that's everything there. I will also commit the Docker Compose with the Olama. And yeah, I guess I can share with you those basic flows, because everything else is I forgot. It stops if you work if you use it as a UI. Unfortunately, if you switch the text, it stops. But yeah, there are some prompts, and I don't want you to focus on the prompts here, because it was made for a fun project for a research here. But this agent actually it's slow. It's super slow. This is some old issue. I guess it was because of the upgrade of Docker. Yeah, it's still on a different loop. Okay, so let me pause sharing, and if there are some questions I can relate it to running those models, Gemma, let me know. I'm really surprised how well Gemma works. Like, come on, it's a 2 billion parameter model, and it gave me pretty good answers to product management things. But adding rack component like we did in here gives us this unfair advantage because it supplies it with more narrow data. So instead of going, 2 trillion parameter models like Claude Anthropic or GPT-4 Turbo, or for regular 4, we were able to use smaller models. We are able to build private apps because 2B was pretty good with the speed, and yeah, have fun while building it. Let me know if you have some specific that you would like to see from Langflow, some specific flows. Very blur, I see. Okay. I guess it is the streaming. So I will share with you then a JSON file. So you can drag and drop those flows to Langflow, and then you will have those blocks. You just need to make sure to upload the custom components, I believe, to make it work. Okay, so with that in mind, thank you guys. Hopefully it was helpful for you, and happy coding for sure. Take care. Cheers.